Okay. All right. Let's look at your group project. The university. There are a lot of other data collections available. So that is one of the repositories that you can refer to. Is it also available or is not? To your web? It's not on your slide? I'll revise the posting. Okay. Manual of all can be found here, www.insiderall.org.all.doc. Okay. If you come here in this all studio, upper left corner shows you some of the resources. For example, if I type in this console library and open and close, then it shows those libraries. The upper left corner, there's that panel. There is also the tabs on top. So if I click this, then you can see that. And packages available. Packages are available. Some packages are available on your own directory, or some others in the system itself. Program files.all /all -3.1.2. That is the version of your RStudio and the libraries. Actually, two repositories, two different sites holding up some of the packages. Your program, R program itself, or your home directory. Upper right corner, it shows you history of your command, R command. There are two tabs actually, or environment. Okay. For example, we created the variable x. Remember that? So that is the x. If I click this, then again, it shows all the data there. All the data that we created, right? So back here. And lower right corner, there's another panel. If you draw some of the data, then it appears in this panel. All right. So this is the library that you could see. You can also include some of the library if you want. Say one of the library here is DTW, Dynamic Time Wrapping. Oh, this is wrapping algorithm. This is some others. Say cluster. And then data, then you can see the all data that you can, data associated with the cluster packages. There is a agricultural data, animal data. Those are all the data sets given from your R studio. So rather than, if you download it or if you create the data, then you have to first clean up the data so that it can be properly manipulated by R. So those are the data already cleaned up, already suitable, so that in this class we'll look at some of this, okay, rather than spending and wasting time on cleaning up and something else. Okay, so if we want to read some of the data, for example, animals, then you can simply type here animal. Then those are the animals. What are they? Here, I don't know what it is, right? Anyone's familiar with the animal behaviors? For example, fly, cat, oh, bee. I like bee. Bee, I don't know, war, fly, whir, and grow, hey, whatever that number is, right? Actually, are you familiar with your healthcare? Your healthcare is not animal healthcare? Okay. All right. So you can read some of the data there. I'm not sure if we can plot that. Plot.
Can you just plot the whole thing?
Animals. Yeah, we can plot that, right? Some of the data. Interesting plotting. Okay. So you can see that. And the next slide, from the next slide, I put here, if you want to set the directory, you can type it or simply come back here and click session button so that you can set the working directory. And if you want to see the list of files, for example, right now, I am where I am. In the console, just right next to the console, there is a path information appears. That is my working directory. So that if you want to see the list of files, then you can type list.files there. So list.files, open and close parentheses, then you can see all the files there that we created. For example, wages, I created this, wages CSV 0.csv, right? Some others.
Where were you saving your files, by the way? I'm having an issue with saving mine. Where have you been saving yours? Can you show me an example where you have been saving it?
In here?
Like, for example, can you show me in your directory where have you been saving your wages file? I know you save it in RStudio.
I don't know what I'm mean by that, but this,
so you save it anywhere.
yeah.
You weren't necessarily saving it in your RStudio. You were just saving it anywhere.
Anywhere, but you can set that working directory on your studio so that your studio right works on that particular folder or directory. Okay, another thing that we need to do, we looked at this and okay, here. So let's try this. Last time we did a random number generation, right? So if I do, for example, all using normal distribution functions, I want to generate 1,000 data sets, then you can have like this, right? What is the command? Is this R for random, NORM, norm. There's a normal distribution functions. You can use some other distribution functions as far as it is implemented here. But if you do not know what it means, then I'm not sure it works here, but question mark norm, then it gives you the explanation of R norm. So normal distribution, sample code that you have here, D norm, P norm, Q norm, R norm. Depending upon N means, hold on, all, is there any explanation of what it is? Genome, Yeah, some of the sample programs also available here. So you can use this. You can play with this. There's a lot of useful sample programs provided to you. What we want to do, let's try, for example, simply all norm. I want to generate how many? 1,000 numbers, and mean value of those numbers are saying, if I put 0, then that should be negative number and positive numbers, right? If I put, for example, 100, that's an average number. And standard deviation, if I say 50, okay? So I want to generate 10,000 data points. The average of those are all 100. So all the numbers somewhere close to 100. And deviation, standard deviation is 50. So maybe smallest number is 50 and a bigger number 150, something like that. Okay? So let's see what happens. So here 104, 180. Oh, this standard deviation maybe a little more than that. Right. Anyway, those are the numbers. All the numbers are labeled. So this number is 996. After that, 997th, 8th, 999th. This is a 1000th. So if you want to access, let's first, I want to name it A. So A is that number. And I want to see 999th, which is this number, right? Can I see that? Yes, that is. So not really that one, right? 93. Where is that number come from? Something else. Not in that order. $196. You're supposed to. But anyway, that is the number. And we can save this number also. If you want to save this number, then PDF, the number itself. See here, we generate that number. I want to save this, PDF, and then file name. Say a.pdf. Okay? Then it is saved there. And when I come here in the directory, then that file is saved. You see here? There's one good thing. And you can test also file that exists. If that file, say a.pdf, does it exist? True. All these things are based upon this directory. This is my working directory. When you save it, it is saved in that working directory. If you want to search, it is searched within that working directory. Let me see. What is mine? Mine is also. I think, I'm not sure. After you close this, right now, if you open this, it is not open. There's some errors. Well, error opening this document is a file. File is already opening this. this has been used right now. This one is using. Maybe the reason, I'm not sure. Okay. So you can read the PDF. This is the I/O. You can read and write any formats like this. You can, for example, read DBF files, database format files, DTA, whatever that is, as an input and output. Another is a distance matrix. Empty cars. Let's try with the empty cars. Empty. Yeah, there's empty cars. Distance empty cars. Distance empty cars. Then we can see some of the distance here. What it does here is for example, we have Mercury 280. There's a distance between Mercury 280 and Mercury 230. Distance is this, 39 point something. Actually, by default, this is Euclidean distance. What is the data? Data is this. So how it was calculated? We have Mercury 280 and something else. If you compare the distance, then you can make distance between, and based on this miles per gallon and number of cylinders, number of discs, whatever that is, horsepower and those things. And then there is a average distance. Okay, that is what they did here in this example. That is called the DIST function. And in this one, we already looked at the reading of CSV files, so we don't have to worry about this. All bind, if you have two different data files, if they are in the same structure, then you can bind them. That's what we did the last time also, right? You can try that, all bind. Okay, and then what we will do is we want to generate the distance of that file, empty cars files, and we call it D. And then we want to cluster based upon that distance functions. We call it HC and plot that HC. Okay, so let's try with that. So let's say
I just blew up my own studio.
A is dist and empty cars. So we generate the distance functions there. And then B equals H cluster, hierarchical cluster of A. And then plot B. See what happens. B, that is already clustered. A, there's a distance functions. Plot B, Usually what happens is that if I have not enough memory reserved for this RStudio, it is not properly plotting. So what I need to do is I want to save this and reopen it. Unfortunately, that is from my experience. So what I want to do is I'm going to reopen it. Oh, everything is gone. It's not really saved. So let me redo. See if we empty cars there. Yeah, empty cars there. So I want to make it distance. I want to generate distance function of the empty cars. And I want to cluster hierarchical cluster of that file A and plot B. It is plotted in this way. Zoom. That is a plotting. Among the cars, there are some cars, right? There's a clusters by weight, by height. According to the height, I'm not sure. If it is height less than 100, then you can cluster, for example, all this together. What are the cars that we get more familiar? Here. Honda Civic, Toyota, Corolla, Fiat, they are all in the similar height, right? So this is reasonably clustered. This is a high H cluster by complete. What is a complete link? There's a furthest distance to be used, right? Rather than the shortest distance. All right. This is the way that you could do. What I want you to do is, there are a lot of data available here. So I want you to try the similar way that we did here. And then let's discuss about that, okay? So let me stop.